This is a write-up for an accidental solution to the Smuggler challenge of the Wolv CTF 2023. In this challenge we are handed a Python file, which is a web service. And what this web service does is it accepts source code and it then compiles the source code with this pre-processed flag. If the compilation fails, it returns the error. And if it doesn't fail, it returns the compiled binary. Here we see the application in action. We can give it some source code like this. And if we press compile, we'll see the elf, we'll get the binary back. If we look at the f preprocessed flag, we can see that it will still recognize and remove comments. So that may come in handy. Let's check that out. Here's an article explaining the steps of a compiler that it uses to create a binary. And if you scroll through this a bit, we can see these comments as was mentioned in the documentation. And I use that to get the flag. So let's do that now. Here we have the application again. If we enter a comment like this, it will actually show the flag. Here's the flag. But now the question is, where did this flag come from? Why did we get this flag? This was actually confusing to me during the CTF. I found a solution because I was just messing around with entering this and it gave me the flag, but I didn't know why. So let's look into that now. If we look at the preprocessor documentation, we can see that we're able to enter these comments, and these are called line markers. And they can actually specify a file name and a line number. So in our case, we specified the file name flag and the line number 1. And then there are flags in these line markers that you can give it to indicate what you want. So 1 indicates the start of a file. So this is what we did. So this indicates that this line, printf, is actually the first line in the file flag, right? And that's all there is to it. Let's look at how the processor behaves when we do this. So here we have a directory with a flag file, which just says writeup, and then we have the pre-processed file as we send it to the server. And now if we try to compile it with the same flags as the server, we will also get the same error. So indeed it shows our flag. Now why did it do that? Why is it showing this as a warning? Well, let's change this to, let's change it like this. So we just have a 1. And if you compile it, then we can still see the warnings. The reason that you don't see the warnings in the CTF challenge is because it doesn't show warnings, it only shows errors. So we need to generate an error and then we'll also see the warnings. So let's now add the 2 again. Well, you know what? Let's just add like a lol test, because actually it doesn't matter what you put here. As you can see, this would also have been a solution. And what happens here is that if you just say printf in a C application, then the compiler will complain that you didn't include studio.h. But it will then try to refer to the part of the code where you're doing the printf. But in this case, we said, oh, this was the first line of the flag file. So it will go to the flag file and it point out like, hey, this piece of code is not correct. But in this case, it reads the flag file, shows the first line, which is the flag in this case. And that was a solution to this challenge, an unintended one. So a big thank you to the creators of the Wolv CTF challenge. It was very fun. And as always, don't forget to like yourself, and I hope to see you next time.